Okay. Thanks for having me. If you look at these glaciers, I guess we all have memories about glaciers. And if the sun is shining and the weather is blue like that, we have very positive memories about the glaciers. But glaciers too have their memories. And these can be very short-term memories. For example, remembering the last ablation season, as you can see here. Memories about the last 30 years of climate, for example, when the glaciers waxed and waned, responding to these climate changes. But also long-term memories that you can extract by drilling, for example, ice cores through the glaciers or through the ice sheets in Greenland and Antarctica. And it's clear now we are in the Anthropocene, so we have entered the Anthropocene where human influences on climate and glaciers are the dominant drivers. And these comparisons, for example, from this glacier retreat, the rapid glacier retreat to the end of the Little Ice Age is a very prominent figure and symbol of this man-made climate change. But we also have to acknowledge that climate and glaciers have also varied in the past, especially in this time period here called the Little Ice Age, so the early 19th century, 18th century. And you see that these glaciers have expanded very far down on the valley floors. For example, Untere Grindelwald Glacier, people have been harvesting this ice and sent it to Paris so the high society could put in some ice cubes in their cocktails. And these glaciers, they allow us then to have a picture of what was driving these glacier changes in the past. Especially here, this is a really unique place on the world because you have a very well monitored glacier, the Untere Grindelwald Glacier, which is just topped by the Fiescherhorn Mountain, which is a place where there's an ice core drilled over 150 meters in depth that covers basically air pollution history over the last 300 years. And we can use this history of air pollution we can extract from this ice core to look into potential drivers of the Untere Grindelwald Glacier variability that is observed in the last 300 years. It was suggested that the end of the Little Ice Age in the Alps on Grindelwald Glacier and also other glaciers was forced by the deposition of soot, so black carbon, that would change the albedo and then lead to increased melting of the glaciers. And we can directly address this hypothesis by looking into now the soot record obtained from this Fiescherhorn ice core. Oh. Okay. Sorry, for some reason I have not the slide here. So I have to just explain you that we could find out that the soot was not the key driver of the glacier retreat, but it was found that soot emissions only increased later, so in the 1870s to 80s, when most of the glacier retreat in the 1850s has already happened. So how can we extract this information? So this is a plot that shows us how the ice core works. So snow is falling. Now it suddenly came. Suddenly, somehow messed up the order of my plot. So we are back now how ice cores work. So we can extract information about the deposition of past impurities on the ice sheets by drilling an ice core through these ice sheets, be it alpine glaciers or Greenland and Antarctica. Then we can obtain ice cores like that, and we can then go to the lab, melt this ice core, and extract the information, the memories of the ice, and, for example, obtain a history of, let's say, soot, of black carbon, but also of other substances that have been deposited on the ice sheets. And we can also date these memories by counting annual layers, for example, sodium, ammonium that have been deposited on the ice core over time. And one of the key drivers of the rapid increase of the glaciers in the early 19th century, for which I unfortunately somehow lost the slide, was a large volcanic eruption, because there was a cluster of volcanic eruptions in the 19th century that forced the glaciers to rapidly expand so that it reached their maximum around 1850. And so we can also extract, for example, information about volcanic activity, about climate activity in the past. And this is one example here now for Greenland, with increased levels of sulfur and ash, shown in the year 44 BC, and that is the year of Caesar's murder in Rome. And then we can go into a repository of the archives, basically a library where all the ice is stored globally. So you have here a cold room in Denver with minus 40 degrees Celsius, which is stored where all the ice cores are stored that have been drilled in the US community mostly. And it's can imagine this like Harry Potter going into the Ministry of Magic, trying to locate the prophecy about him and Lord Voldemort. So the task was to find the specific piece of ice that would contain information about this large volcanic eruption dating 44 before Christ. And I think we were successful in finding ash particles in this sample of the ice core here, and we could geochemically characterize it and pinpoint it to a specific volcanic eruption, and that is here. Okmok was a very large caldera-forming eruption in the northern Pacific, in the Aleutian chain of Alaska, and we can date it now firmly to fall 44 BC, and it released massive amounts of sulfur into the stratosphere and therefore affected climate. And so we can, by collecting these memories of the ice cores, we can then also create a storyline that links this volcanic eruption, it's a very major volcanic eruption, with extreme weather reports that have been coming out from the Mediterranean region. We can link it to famines and crop failures, and also to historic figures like Cleopatra and Brutus that try to adapt to these changes imposed by the emissions of sulfur and ash into the atmosphere. So memories become stories and finally also history. And these memories are getting lost. So you see here an example from last year's season in the Alps, which really started with a very high snowpack, but towards the end of August, it was another bad year, just like the 2 years before. And these memories are very, very fast lost. So this is another example, Grand-Gobain, 2018, they drilled an ice core up here to the bedrock, and then 2 years later, they came back, tried to drill another ice core, but they were drilling into the water table, couldn't penetrate the ice core anymore because there was water standing in the ice core, and that all just happened within 2 years. And this warming is then, of course, affecting the ability of the ice cores to store these memories. You can see the comparison of the sulfate records, for example, which are classical pollution records from man-made emissions, and they should look the same if they haven't been distorted, but the younger ice core drilled 2 years later, all the originally deposited sulfate has basically been washed away and has been refrozen or redistributed. So this memory is basically lost, and this ice core has no value for science anymore. And for this reason, some researchers like Jérôme Chapelain, Carlo Barbante, Marek Zwickowski have set up this Ice Memory Initiative, which has the goal to collect, save, and manage ice cores from selected glaciers in danger of disappearance to preserve the memory of these glaciers for the decades and centuries to come. And this initiative has collected ice cores over the last 10 years, and they're continuing to do this. So, for example, here, Coligny-Fetti in the Swiss Alps, in the Andes, Illimani in Bolivia, in Siberia, Beluga. And I would like to show you one video that is summarizing that on behalf of the Ice Memory Foundation. It should hopefully play now. So the goal of this project is, of course, to save as many ice cores as possible. I think Kilimanjaro was also on the table. I saw that Doug Hardy is listening, so I think the drilling expedition on Kilimanjaro didn't work, but at least a few of these memories should be preserved by collecting these ice cores now and storing them in Antarctica, so that researchers, climate researchers, and ice core researchers can study them in the future. And maybe one last word on Greenland. Of course, I've done most of the work on volcanism in the past in using ice cores from Greenland and Antarctica. And here, of course, the urgency isn't as strong because you have still very cold conditions in the interior. So we have still very good and intact ice core quality in Greenland. But even in Greenland, in very remote places, ecosystems are changing rapidly. For example, polar bears encountering drilling camps has been an issue over the last years. So when we drilled this ice core in 2013, we didn't have any guns, and nowadays we can no longer enter Greenland without carrying rifles with us because of polar bears who are wandering Greenland in search for food. So there's also changes coming into the Arctic and Antarctic region, but of course the high alpine region are in greater danger and greater urgency. Thanks for your attention.
Thank you very much, Michael. Your talk reminded me of the fire that destroyed the